Hi, let's continue with our session. In this video, I want to talk about ANN. So while neural networks are really cool, we cannot just use a single neuron to perform complex tasks. This is the reason why our brain has billions of neurons stuck in a layers, forming a network. So similarly, artificial neurons are arranged in layers. Each and every layer will be connected in such a way that information is passed from one layer to another. So a typical ANN consists of the following layers. So we have the input layer, hidden layer, and the output layer. So each layer has a collection of neurons, and the neurons in one layer interact with all the neurons in the other layers. However, neurons in the same layer will not interact with each other, with one another. So this is simply because neurons from the adjacent layers have connections and edges between them. However, neurons in the same layer do not have any connections. We use the term nodes or units to represent the neuron in modern artificial intelligence networks. So this is a typical ANN is shown in the diagram. So we have the input layer, hidden layer, and the output layer. So now let's talk about the first layer, which is the input layer. So the input layer is where we feed in input to the network. The number of neurons in the input layer is the number of inputs we feed to the network. Each input will have influence on predicting the output. However, no computation is performed in the input layer. It is just used for passing information from the outside world to the network. So now let's talk about the hidden layer. So any layer between the input layer and the output layer is called the hidden layer. It processes the input received from the input layer. So the hidden layer is responsible for deriving complex relationships between the input and the output. So that is the hidden layer identifies the pattern in the dataset. It is majorly responsible for learning the data, representation, and for extracting the features. There can be any numbers of hidden layers. However, we have to choose a number of hidden layers according to our use case. So for a very simple problem, we can just use one hidden layer, but while performing complex tasks such as image recognition, we use many hidden layers where each layer is responsible for extracting important features. The network is called a deep neural network when we have many hidden layers. And now the last layer is the output layer, so let's talk about that. So after processing the input layer, the hidden layer sends its results to the output layer as the name suggests. The output layer emits the output. The number of neurons in the output layer is based on the type of the problem we want our network to solve. If it is by binary classification, then the number of neurons in the output layer is the one that tells us which classes the input belongs to. So if it is a multi-class classification, say with 5 classes, and if we want to get the probability of each class as an output, then the number of neurons in the output layer is 5. Each is emitting the probability. If it is a regression problem, then we have one neuron in the output layer. And that is all in this video, so I hope you enjoy it, and I will see you in the next video.